Vaughn.
All good? Okay. Yeah, what do we look like? All right. Okay. Well, I can't see what we look like. Yeah. Okay. That's cool. Okay. So today we're going to be talking about the Great Valley. The Great Valley is a geomorphic province in California. To be specific, a geomorphic province is an area of land that is separated by its unique geology from its surrounding. As you can see, there are several different types of geomorphic provinces in California. Almost all of the rocks formed in the Great Valley are sedimentary rocks. Some of the most common rocks you can find in the Central Valley are sandstone and different types of alluvium. Alluvium is a deposit of clay, silt, sand, and gravel left by flowing streams in a river or delta. What's important to understand about alluvium is that alluvium is loose, unconsolidated soil or sediment that has been eroded and reshaped by water in some form and redeposited in a non-rain setting. Another important note is that sandstone in the valley was formed in a marine or ocean environment, which is the opposite of the alluvium. The last important outcropping of rocks are the Sutter Buttes, which are what is left of a volcano that has been dormant for about 1.4 million years. The rocks here are a rich mix of both sedimentary and igneous rocks. The igneous rocks of the Sutter Buttes are what make them stand out compared to the rest of the valley, which is solely made of sedimentary rocks. The oldest rocks in the Great Valley can be dated back to the late Mesozoic era, with most of the rocks falling somewhere in between then and the Quaternary area. The ages of the rocks in the valley are generally more recently formed the closer you get to the center of the valley. Originally, the Great Valley was an ocean bed. The rocks formed in this period of time came from sediments being deposited on the ocean bed and then forming into rocks. Many of the sediments being deposited came from the Sierras getting eroded. What's important to understand about this is the scale of the sediments being deposited in the Great Valley. The Great Valley sedimentary rock layer is around 40,000 feet thick. The Great Valley would later transition from an ocean bed to a Great Lake. Rocks during this time period were formed from sediments being deposited on the sides of the lake or on the lake bed. While the Great Valley is now no longer underwater, it has still retained its relationship with water. Today, the Great Valley contains some of the largest rivers in California, with most of the rocks that are formed today coming from above ground river deposits. 1 second, sorry. There we go. Okay. The Great Valley is one of the most fertile areas you'll find anywhere. The Great Valley has a great climate and an abundant amount of water, which creates a great farming environment. However, the most important part of the Great Valley's fertility is its soil. Alluvium soil, which has already been weathered by water, is especially rich due to the fact that the chemicals released by minerals when they are weathered down is incredibly beneficial for soil. To be specific, the soil is so rich because it's full of minerals such as mica and feldspar. These minerals are abundant in chemicals like potassium, magnesium, and calcium, which are essential to plant growth. Thanks to the area's fertility, the annual value of agricultural products grown in California exceeds $32 billion, with most of its products being grown in the valley.
Moving on to plate tectonics, the Farallon plate subduction is the subduction of an ancient oceanic plate that moved underneath the Pacific plate. This process took roughly 200 million years, as the true start date is unknown. It was caused because of Pangaea, the last supercontinent, breaking apart. The area in which the subduction occurred was along the North American coastline. Here's a rough diagram of what happened during the Farallon plate subduction. And as you can see on the top of the diagram, the Great Valley sedimentary sequence is underwater at this time, as Nate explained. Moving on to the western assemblage. The western assemblage of the Great Valley is the most eastern part of the San Franciscan assemblage, but is still considered to be at the edge of the Great Valley. As for section A on the map, that region consists of old marine sandstone and shale, which are rocks that you could find very deep in the Great Valley itself. The reason why they can be seen here at the surface is due to the Farallon plate subduction. As for B, the older sedimentary rocks being exposed on the surface is also a result of the Farallon plate subduction. These are just different types of rocks. There are also rocks that you may find as much older, deeper layers of the Great Valley. And moving into C, which is the valley itself, it's just the modern alluvium or sediments, soil, whatever you want to call it, that are a result of water erosion. And here's a diagram that represents how these western rocks were bent upwards by the Farallon plate subduction. As you can see on the left, these rocks were bent upwards at a pretty steep angle, which is why you can see them on the surface. Moving on to the field trip for our field trip, we will be traveling onto the Sutter Buttes, which is a volcanic range that is right in the middle of the Great Valley. The Sutter Buttes were originally formed during the Pleistocene epoch, or 1.6 million years ago. However, the Sutter Buttes are far more than just some random dormant volcano. It is also believed that the Sutter Buttes either represent the southernmost boundary of the Cascade Ranges, which is another range of volcanoes, or are in some way related to the volcanoes of the California Coast Ranges. From the San Andreas Fault to the many volcanoes in the state, California is bristling with volcanic activity. However, of the geomorphic provinces, the Great Valley is one of the more peaceful provinces volcanically wise. It has no other major mountains or volcanoes to speak of outside of the Sutter Buttes. This is why the Sutter Buttes are so important to the rest of the province. As for more of the specifics of the field trip, the Sutter Buttes protruding figure exposes some of the valley's sedimentary based layers, just like the western side of the valley, and this provides a great insight as to how and when the valley was formed. It will also provide an opportunity to look at some of the recently formed extrusive igneous rocks that were formed as a result of the volcano itself. The Great Valley also has an iconic bowl shape due to both the Sierra Nevada Range's erosion and the Farallon Plate subduction. And the Sutter Buttes, with their height, are basically one of the only locations inside of the valley that provides a great view of this bowl shape, making it an even more ideal location. They make you wonder how they even got there in the first place and offer a direct correlation to the surrounding areas. If we can understand how the Sutter Buttes came to be, then we can begin to better understand the surrounding regions. And that is it. We would like to acknowledge Cole and Mr. Bisman for helping us with our project and presentation. And here's our sources. And thank you.
Thank you, gentlemen.